On Saturday night, May 31st, something is coming to the sky that hasn't happened in 6 years and won't happen again for another 27. A full moon will rise in the east, but this isn't ordinary. It's the second full moon in a single month, which means it earns a name nearly everyone has heard, but almost nobody truly understands. A blue moon. But here's what makes this one worth your attention. Right now, the moon is drifting toward the most distant point in its entire orbit around Earth, further than it will reach at any moment this year. So when it climbs above the horizon Saturday night, it won't just be a blue moon, it will be the smallest full moon of 2026. Not dramatically smaller, but visibly, measurably different from those enormous moons you witnessed in November and December that seemed to devour the horizon. This one hangs further back, quieter, smaller, and directly beside it, burning a deep crimson red, will be one of the most visually striking stars in the entire night sky. We're walking you through what's actually happening, what you'll see, and how to find it. And if you stay through the end, you'll discover that 9 days later, the two brightest planets in the solar system are going to converge in the evening sky, in a spectacle you genuinely don't want to miss. So why is it called a blue moon? The honest answer, it's a mistake. The modern definition of a blue moon as the second full moon in a calendar month originated from a 1946 article in a popular astronomy magazine, where the author misunderstood an older, more complex definition. That original definition referred to the third full moon in a season containing 4 instead of the usual 3, a completely different phenomenon. The 1946 error spread rapidly, and by the 1980s the misinterpretation had become so widespread through radio broadcasts and popular media that it became the accepted definition. Today, when people say blue moon, they mean the second full moon in a month, even though that's technically the result of a historical mistake. As for the color, the moon will look exactly as it always does. Bright, white, fully illuminated. The only time a moon actually appears blue is when fine volcanic ash or wildfire smoke particles scatter red wavelengths of light and permit blue ones through. A genuinely rare atmospheric event that has absolutely nothing to do with the calendar. Now here's what makes this particular blue moon genuinely compelling. The moon doesn't orbit Earth in a perfect circle. Its path is slightly elliptical, which means its distance from us changes constantly throughout its monthly cycle. The nearest point in that orbit is called perigee. The most distant point is called apogee. When a full moon occurs near perigee, close to Earth, it appears larger and brighter than usual. That's a supermoon. When a full moon occurs near apogee, far from Earth, it appears smaller and dimmer than usual. That's a micromoon. On May 31st, the moon reaches its furthest point from Earth for the entire year. It will be roughly 13,500 miles, or 22,000 kilometers, further than its average distance. That makes this not just a blue moon, but a micro-blue moon, the smallest full moon of 2026. Compared to an average full moon, it will appear approximately 7% smaller. Compared to a supermoon, the kind you witnessed in November or December, it will appear 12 to 14% smaller and 30% dimmer. In practice, that difference is subtle enough that most observers wouldn't detect it without a direct side-by-side comparison. The moon will still be full, still luminous, and still absolutely worth stepping outside for. But if you've ever gazed at a supermoon and felt like it seemed unusually massive and close, the moon on Saturday night will feel like the inverse of that. Blue moons themselves only occur every 2 to 3 years. But a micro-blue moon, a blue moon that simultaneously happens to be the furthest full moon of the year, is genuinely uncommon. It occurred in 2020. It's occurring May 31st, and then not again until 2053. That's a 27-year interval. The micro-blue moon reaches peak fullness at 8:45 UTC on the morning of May 31st, which translates to 4:45 a.m. Eastern Time, well before sunrise across most of North America. That means the optimal time to observe it is actually the night before, On the evening of Saturday the 30th, when the moon will already be more than 99% illuminated and rising in the east as the sun descends in the west. Head outside after darkness falls, look toward the east, and you'll find a full, bright moon ascending above the horizon. But here's the detail that makes this particular evening especially worth seeking out. Close to the moon, radiating a warm reddish-orange glow, will be Antares, the brightest star in the constellation Scorpius, and one of the largest stars visible without optical aid. Its name in ancient Greek roughly translates as rival of Mars, because its red color so closely resembles the red planet. On the night of the micro-blue moon, the moon and Antares will sit near each other in the sky, a bright white-gray moon and a warm red star, positioned side by side against the black. No telescope required. Just a clear sky and a view toward the south-southeast after dark. If the micro-blue moon gets you outside looking upward, don't stop, because something has been developing in the western sky for weeks, and it's worth observing every single evening between now and June 9th. Venus and Jupiter, the two brightest planets visible from Earth, are slowly converging in the sky. Step outside tonight after sunset, look west, and you'll identify them immediately. Two extraordinarily bright objects above the horizon. Venus is the more brilliant one, blazing, impossible to overlook. Jupiter sits just above it. And here's what's remarkable. Every evening you step outside and look, they'll be slightly closer together than the night before. It's gradual, but it's visible. And watching it unfold night by night is genuinely one of the most satisfying experiences you can have as a casual observer. On June 9th, they reach their closest approach, just 1.6 degrees apart, approximately 3 moon widths of sky separating them. Head outside as evening twilight fades to darkness. Look west-northwest, and there they'll be. You'll have roughly 1 hour before they sink below the horizon. So don't delay. No telescope, no applications, no equipment. Just step outside, look west, and watch two of the brightest objects in the solar system slowly find each other in the evening sky over the next 2 weeks. The coming months are among the finest of the entire year for looking upward. First, the Milky Way season returns. For several months every summer, the luminous core of our galaxy becomes visible from Earth. And if you can reach somewhere away from urban lights on a clear night, you can witness the entire arch of it stretched across the sky. If you've never observed it with your own eyes, make this the summer you do. It doesn't photograph the way it actually feels. Then comes August 12th, and that date is genuinely extraordinary. On the same day, a total solar eclipse will sweep across Greenland, Iceland, and Spain, with a partial eclipse visible throughout much of Europe. And that identical night, the Perseids, the most beloved meteor shower of the year, reach their peak under a completely dark, moonless sky. You can observe up to 100 meteors per hour, an eclipse and a major meteor shower on the same day. That alignment of timing essentially never occurs. Right now, on May 31st, the smallest moon of the year rises in the east. Beside it burns Antares, red and ancient. 9 days later, Venus and Jupiter converge in the west. And 3 months after that, the sky delivers an eclipse and a meteor storm on the same night. All of it visible. None of it requiring equipment. Just a clear sky and the willingness to look up.